All right, so we just last lesson finished up the day one for sine and cosine. Today is really just working with it, seeing some different types of problems. Partner practice, you don't need partners. Well, you can work with a partner, just make sure they're more than 6 feet away, right? Okay, so we're just going to do a couple of these problems and practice with what we've been practicing with, and then just introduce different ways to ask questions based on the relationship between sine and cosine. Again, because they're the same thing when you're working with its complementary angle, right? So again, different ways to ask questions here. We have sine of A, and we're assuming we're going to assume A and B are complementary angles, right? So we have angle A, which is over here, and we have angle B, which is over here. So in this example, right, angle C is 90, so A and B are complementary. So if they're complementary, then we can draw these conclusions. So sine of A is 0.7832. You might say, why do we use 4 decimals? When we represent trig ratios, guys, it's usually 4 decimals. Everything we've done through this week has been kind of more to do, like they work out evenly, like 29, 28ths or whatever. As fractions, they're great, but if they're not fractions, usually we do 4 decimals. All right, so what is 2 sine A plus 2 cosine B? So just like with the end of the last lesson, I don't want to work with different angles. I'm going to try and change cosine of B so that the same thing as A. So cosine of B is the same thing as sine of A. So I'm going to say, all right, this question is really asking me what is 2 sine A plus 2 sine A, because it's a different way to say 2 cosine B. So it's basically 4 sine A, and if I know sine A is 0.7832, it's 4 times 0.7832, which obviously you could do that right off the top of your head, yeah? 3.132, right? You could use it, you can multiply it out, you can use a calculator, it's not that big of a deal. All right, second question. Sine of 66 degrees and 24 degrees. All right, well, what do I know about 66 and 24? Well, if I add 66 plus 24, I get 90. So what does that mean about 66 and 24? It means they're complementary, which means the sine of one is the same thing as the cosine of the other. So again, I would just, change either one of these. I'll change this one just for the, keep it fresh. I'm going to say sine of 66 is the exact same thing as cosine of 24. Or you could have changed cosine of 24 to sine of 66. But basically, you're going to get some number minus itself. So the answer is going to be 0. Here we go. Different way to ask the same question or a similar question. Again, I see that I have an angle here that's not the same as the other ones. So I'm going to change sine of A plus, I'm going to say cosine of A instead of sine of B, because I can't make any conclusions about A and B. I can't do anything with those. They're different variables. You can't combine them. You couldn't say that it was 2 sine AB or anything like that. You can't work with them if they're different variables. So if sine of A plus cosine of A over sine of A. Now I can't, sine of A plus cosine of A doesn't equal anything. So what I'm going to do is I'm going to break up this fraction so that it's sine of A over sine of A plus cosine of A over sine of A, right? I'm going to break up the denominator into 2 parts. That way I can make sense of it, right? If I gave you 1 plus 2 over 3, that's the same thing as 1/3 plus 2/3, right? So essentially what I'm doing here, I'm giving the denominator both parts. So sine of A plus sine of A, sine of A divided by sine of A is just 1. So I'm going to have probably 1 in here, right? There's my 1. And then if I look at the other part, cosine of A divided by sine of A, oh, I remember that from the last lesson. That's going to be tangent of A, right? So I'm going to have, oh, I'm sorry, I just screwed it up. Cosine of A divided by sine of A is cotangent, right? If it was sine on top, then it would be different. So my final answer is going to be 1 plus cotangent of A. Which could also, if you change these to B's, you would have gotten 1 plus tangent of B, which is the same thing as 1 plus cotangent of A, the exact same thing, right? Tangent and cotangent are also complementary, just like sine and cosine, just like secant and cosecant. That was like the activity from the last class, so the answer to those 3 questions you had from last is they're all the same, right? Okay, last question here. Cotangent of 88 degrees, tangent of 2 degrees, 3 cotangent of 88 degrees. All right, immediately my mind is going to go right to this 2 degrees. It's the only angle that's different. So instead of saying tangent of 2 degrees, I'm going to say cotangent, complementary, of 88 degrees, because that's the exact same thing, just like with sine and cosine, which is this note here. So here we have cotangent of 88 degrees divided by 1 cotangent of 88 degrees plus 3 cotangent of 88 degrees. So I'm going to get, in the denominator, it's going to be 4. Well, let me just write it up here. It's going to be 1 cotangent of 88 degrees divided by 4. I'm just going to put ditto marks here. 4 cotangent of 8 degrees. These are going to cancel. My final answer is going to be 1/4, right? Or 0.25. So just different ways you can ask very similar questions which all have to do to the exact same standard, and that is sine of one angle is the same thing as the cosine of its complement, right? And here's another way to do it, right? Another way to ask the same question. We're going to solve for the missing variables here. So this is an equation. It's a little bit different here. It's not an expression, right? It's not like we have to simplify an expression. We're going to solve an equation. So the sine of one angle equals the cosine of the other angle. So because, right, sine and cosine usually don't equal each other unless they're complementary. So again, if sine is equal to the cosine of something, what does that mean about this angle and what does it mean about this angle? Well, it means that they're complementary, right? That's the only way for the sine of one to equal the cosine of the other, right? Sine of 30 degrees is the same thing as cosine of 60 degrees, but sine of 31 degrees is not the cosine of 60 degrees, right? So that means there's something special about these two angles, right? And that special thing is they have to add up to 90, right? 3a and 15a have to be a total of 90 degrees between them, right? The other examples we've used were, 88 degrees and 2 degrees, or 67 degrees and 23 degrees. So all you can ignore the sine and the cosine at this point. The fact that sine is equal to cosine means these two angles add up to 90. So we can solve that by saying, okay, well, 3a plus 15a will equal 90, and there you go. Now you can actually solve for a, right? So it's a hidden problem that you don't see on the outset, but it's using your understanding of sine and cosine to get the fact that these two angles have to add up to 90. So same thing here, right? We have cosine of a plus 7 is sine of 3a minus 1. What does that mean about these two angles? They will have to add up to 90. So a plus 7 plus 3a minus 1 is going to equal 90. Combine your like terms and you'll get your answer, right? Same thing with this one, guys. Tangent and cotangent, they are right? They're complementary. That's what the co means. I could have used secant and cosecant, same thing. So you're going to get 6x plus 7 plus just 4, right? It's going to equal 90. And then you can get your value of x that way. Here we have just a trickier way to do it. Tangent of x, cosine over sine. We know that that's the same thing as cotangent, right, of 2x minus 9. So I'll just write that 2x minus 9. That's the same thing as this. So these x and 2x minus 9 have to add up to be 90 degrees the exact same way. So you'll get your answer of 33. And here we get tangent of x equals cosine of 2x minus 9 over sine of 2x minus 10. Interesting here. So this one is a trick question, right? You can't simplify this. Cosine divided by sine is not going to reduce to cotangent unless the angles are the same, right? 2x minus 9 and 2x minus 10 are different angles, so you cannot do anything with them. You can't simplify them. You'd have to know each one's value and then go from there, so you don't. So this one is a do not bother even trying. You can't do it, right? It would only simplify to cotangent, which you could then further make sure that they equal 90. If these two angles are the same, you cannot simplify this into cotangent, right? It just wouldn't work. So just some other practice to do this stuff. You got you don't have to worry about this. Little different instructions. You don't have to create your own questions. But that's it. Good job this week, guys. Not easy stuff, but I'm sure you guys are getting it pretty good, which is great.